Welcome to Unit 5, Lesson 8, Unknown Exponents Practice Problems. Okay, a pattern of dots grows exponentially. The table shows the number of dots at each step of the pattern. Write an equation to represent the number of steps that dot y. All right, so we just basically need to write y in terms of x. So y, remember, when the horizontal tables, the top is our x, the bottom is our y. We start at 1. We're multiplying by 5 to the x power. That's it. At one step, there are 9,765,625 dots in the pattern. At what step will this happen? Explain how you know. This is how we know. We're going to hit the y equals button on our calculator. We're going to put this equation in, and we're going to hit second graph, and we're going to read the table of values. Now, when you read the calculator, because the numbers get so big, and the calculator can only put 6 digits into a thing, this is what you're going to see. When x equals 10, the number you get is 9.77 E6. This E means times 10, and the 6 is the exponent. So what we do from here is scroll down to 10 and then right arrow over, and in the bottom, it will say y1 equals 9765625. So this tells us when x is 10, at step 10, that's when we get our 9 million dots, 9.7 million dots. So what we did was we scrolled down to 10, then we right arrowed over on the 9.7 EE6, and in the bottom of the screen, you see the exact number. And this will be helpful in the future because we're going to have to round to the 4th digit behind the decimal. A bacteria population is modeled by pH of 10,000 times 2. So that means it's doubling every hour. So that's what it means. How long will it take for the population to reach 100,000? So basically what we're going to do is put this in a y equals and see when the number is 100,000. So we hit the y equals button. We type 10,000 parentheses 2 to the x power, and we know we had to hit the caret to get the x up. We hit second graph. So when x is 3, y is 80,000. When x equals 4, y is 160,000. So x has to be a little bit bigger than 3. So because it's 100,000 is closer to 80 than it is 160. It's only 20,000 away from 80 and it's 60 away from 160. Okay, the beautiful thing about tens is all you got to do is count the zeros. So watch this trick. You're going to love this. 1, 2, 3, 4 zeros, -4. 1, 2, 3 zeros, -3. 10 to the anything to the 0 power is 1. To the 1/3 is the cube root of 10. Anything to the first power is that number. 3 zeros, 9 zeros, that gets a 9. Okay, so here's a graph of y equals 3 to the x. What is the approximate value of x satisfying 3x equals 10,000? Okay, so basically what we're going to do is we're going to go over from 10,000 straight over. And come straight down. And since it's so close to 8.5, remember, there are 2 jumps to get to a number, so that's half. It's probably close to a half, so I'm going to say x equals, is about, not equals, is about 8.4. Okay, so let's look at this one. So our money in one account 1, doubles every 2 years. So we don't know what the original amount is, but our B is doubles, but this is X over 2. And the amount of money in our second account triples every 3 years. So this is 3 to the X over 3. So which account is growing more rapidly? So let's run down a table of values. So we're going to put them both in a calculator at the same time, and we're going to compare our numbers. So if we look at a common denominator of 2, that gives us the bottom fraction of 2/3. Let's try 6. When X is 6, because I can just scroll down. In 6 years, the account has went up 8 times. Our money went up 8 times. And in the second account, it went up 9 times. So over a long period of time, you would rather have your money in the second account. So if we looked at 12 years, looking at common denominators, which gives us whole numbers. So this is 6 years. And then in 12 years, because 6 divided by 2 is 3, 6 divided by 3 is 1, 12 divided by 2 is 6, 2 to the 6 is 64, 12 divided by 3 is 4, 3 to the 4th is 81. So the longer you leave it in there, the more your money has to grow. So I would choose the one with the higher interest rate personally. Okay, describe how the output increases in the growth factor for these two intervals, inputs 1 and 2. So at 200 and 2, 100 to 200, it doubles. So the output goes up, it doubles. Now from 3 to 4, what does it do? Say 400 and then say 800. It doubles again. So it's the same rate. Even though the outputs are different, it's still doubling on each interval. The same interval of time, the same growth. Okay, so let's look at this one. Half-life. So our rate is 1/2. We're going X over 5730. How much did we start? We started with 3. Okay, so now what we're going to do is we're going to put this into the calculator. And then after we put this into the calculator, before we hit second graph, we're going to hit second window. We're going to scroll down. Table start. We lead it, make sure that's 0. That's the first line, says table start. That's the start of the table. We always want to start our table at 0. We could always go up and down from 0. Now the second line is delta table. That means the change in the table. We want to change this to 5730. So we only read 0, 1, 2, 3, 4, 5 times 5730. We're not going to see the 57. Well, we will see the 5730s. So we're going to see 5730, then 11. What was it? 460. Then plus 57 was about 16 something. 17 something. 17 plus 5 was 22. So it's about 23 something. Okay, we'll get the exact numbers off the calculator. So here we go. Now that I put it in the calculator, 5730, we got 1.5. That's half is left. And then half of that is 0.75. And that's at 11,460. 17,190 is the next number. We're at 0.375. 22,920 is the third number. So I said 23 something, but it was 22,920, 1875. At 5, we're at 0.093875. Wait, I put too many numbers in there. I'm sorry. 0.09375. Now, on your calculator, you see 0.938. That's why I put the 8 in there. I'm sorry, I was looking at two different numbers. What you want to do is scroll down to X to 28,650, right arrow over. Once you right arrow over, down in the bottom, below the table, you'll see the exact number. So 0.1, so it's about 5 years, 5 half-lives, I'm sorry, 5 half-lives. So when X equals 5, which is 28,650 years, there's a little less than 0.1. Y is a little less than 0.1. So it's a little less than 28,650 years.